So thus far we've talked about synthesis reactions and decomposition reactions. And the next type of reaction we're going to talk about is single replacement reactions. And so what happens in a single replacement reaction is you have a compound and another element comes along and kicks out one of the elements in that compound. So imagine two people are dancing and you have someone come in, kick one of the partners out, and now you've got a new compound and a new element all by itself. So here are some of the rules for you to keep in mind when we're talking about single replacement reactions. The first one is that the positive ion, also called the cation, is going to switch with another positively charged ion. So the atom that comes along to kick out a partner, if it tends to have a positive charge when it is an ion, it will kick out another positively charged ion. If the atom that comes along is negatively charged when it's an ion, it's going to switch with a negative ion. Okay, so positive kicks out positive, negative kicks out negative. And when we're writing a compound, remember you always put the cation first. All right, and finally, in order for an element to kick out another element, it has to be higher on the activity series. If it's not higher on the activity series, it will not kick it out. All right, so let's look at some examples. I've got magnesium, and magnesium is going to go and it's going to try and kick out either silver or chloride. And so we got to figure out which one it's going to try and kick out. Well, magnesium, when it's an ion, is positively charged, which means that magnesium is going to try and kick out silver because silver is also positively charged. So magnesium goes in, and if we look at the activity series, which is in your workbook, we'll look at it more in class. Magnesium is higher on the activity series than silver is. So magnesium will go in, it's going to kick silver out, and it's going to form a new compound with chlorine. In order to write that new compound, I've got to cross my charges. So magnesium and chlorine, cross my charges, I get MgCl2, and silver is now by itself because it got kicked out. And the last thing I've got to do is balance, so I'm going to put a 2 in front of AgCl and then a 2 in front of Ag, and I'm done. If we look at the next example, bromine is going to go in, and it's either going to try and kick out Na or I. Well, bromine, when it's an ion, has a negative charge, which means it's going to kick out the negatively charged ion in that compound, which is iodine. So Br is going to go in, kick out I. So Na and Br are now going to be partners, and iodine is going to be by itself. Now, iodine is diatomic, so it's going to be I2. All right? Now I've just got a balance with a 2 and a 2. And that's it.
So one last thing that you need to check before you finish a single replacement reaction is to make sure that the reaction actually occurs. So in the example that I had, magnesium reacting with silver chloride, I assumed that magnesium would automatically go in and kick out silver, but I didn't check. Okay? So this is how you check. You're going to use what's called the activity series. And in order for an element to kick out another element, it has to be higher on the activity series. So in this example, magnesium is kicking out silver, and it can kick out silver because it's higher on the activity series. If instead you had Ag reacting with MgCl2, Ag wouldn't be able to kick out Mg because Ag is lower on the activity series. Let's now check the second example, bromine kicking out iodine. Bromine is above iodine, so bromine can kick out iodine. But if you had I2 plus NaBr, in that case, I2 wouldn't be able to kick out the Br because it's lower on the activity series, and therefore it wouldn't be able, so when it doesn't work, what you simply write is no reaction.